Oh man, this is like the beginning of chapter 6, the basics of bonding. Okay, chapter 6, part A. Looking at the basics of bonding between the atoms themselves. There'll be another time we'll talk about how molecules hook up. But now we're going to check out how is it that atoms hook up by themselves. Now, there is a thing called second law of thermodynamics. And the thing is that things tend to lose energy. Atoms naturally want low energy. Well, wait a minute. Why? It's a stability thing. Why is it that the atoms bond? Well, because one, they lose energy, and two, they gain stability by doing it. It's kind of like people. Most people out there don't want to be alone. They want to be in a relationship with somebody. God wants a relationship with us. That's part of the Christian walk. It's not about a bunch of do's and don'ts lists. It's a question of having a personal, meaningful relationship with God. There's stability involved in that. Let's talk about the octet rule. So, in the octet rule, octet, you can think about the number 8, 8. Okay? And this happens when you have an atom that has its full valence shell of electrons. So what do you mean valence shell? The outermost level shell of electrons. And who cares, what difference does it make? Well, guys, that's when the atom is at its maximum stability. That's the point. Okay? So how does that happen? Well, there's only two things that are going to happen. Atoms either pick up electrons or they lose electrons. Gain or lose. It's one of the two. Okay? And the whole purpose of doing that is to fill that valence shell, that outermost shell. Again. So when we look at bonding between atoms, okay, there's three ways to look at it. You have covalent bonding, where, excuse me, electrons are shared. You have ionic bonding, where one electron is transferred to the other. And then we have metallic bonding, which we'll get into a little bit later. But in the covalent bonding, we have polar covalent and non-polar covalent. Okay? Usually when people hear the word polar, what comes in their mind? They think about the North Pole. They think polar bear. Or maybe if you're a fan of Happy Feet, the South Pole with Mumble, the dancing penguin. But they'll never compare to the Madagascar penguins. They're heroes. Okay? So covalent bonds, how is it that they work? Well, electrons are shared between the two atoms. It could be shared equally, and that's when we get the nonpolar, or they're shared unequally, in which there's polar. So we're looking at polar versus nonpolar here. Well, wait, how does that work with this equal, unequal thing? We'll get there. So let's take a look at a nonpolar covalent bond example where we can take two hydrogen atoms bond, it's nonpolar, because the electrons are shared equally with each other. Hey, how do we know that? Well, because the atoms are the exact same type. Okay, that's a huge difference. So it's going to be a nonpolar covalent bonding. There is an equal sharing, and life is beautiful, and that's how hydrogen rolls. Guess what? This would also happen with O2, oxygen. Again, it would be a nonpolar covalent bonding because you have two of the exact same type of atoms and they're going to share electrons with each other equally. Well, what about the other side? What about polar covalent? Well, what if hydrogen hooks up with the fluorine atom? How do they bond? Well, here's the thing. You might remember that fluorine atom has a greater electron affinity than the hydrogen atom. Fluorine overall is more interested in the electron than the hydrogen atom is. If you don't remember electron affinity, check out the previous chapter. We get into that. Okay, so what you have here, you have a picture of a hydrogen atom and a fluorine atom. And they're in a tug of war because this one little electron is there. Now you may notice that the hydrogen atom has a slight little positive charge there, and the fluorine has a negative charge. Well, where's the electron? Well, the electron is right here. Okay? If we're looking at a tug of war, and this is the halfway point, guess who's winning the tug of war? It's the fluorine. But does fluorine win the war totally? No, because hydrogen is still holding on to it. They're shared, but it's an unequal sharing. So what you end up getting in a hydrogen fluoride molecule, or hydrofluoric acid if you will, you'll have an area of positive charge and an area of negative charge. This is what they call the polar. Okay? This is what they refer to as the polar. Now we can have polar molecules, we can have polar bonds. Now in this case here, because we have one atom of each, they get together, you have a polar molecule because you have a positive end and a negative end. But this is a polar covalent bond. So there is a way to predict this. We can talk about electronegativity. Electronegativity is the ability of an atom in a bond to attract shared electrons. Okay? The ability of an atom in a bond to attract shared electrons. So the range goes from a low of 0.7 to a high of 4.0. So the smaller the number, you don't have quite the same ability, you don't have a very much ability to attract shared electrons. But if you're at 4.0 higher, you are more likely to attract the shared electrons. So depending on the delta En, okay, what's going on here? Electronegativity difference. The bonds range from nonpolar to highly polar to ionic, because you have to look at the two atoms together and subtract their electronegativity values. You're going to come up with a number, and that number, depending on that difference, it's going to tell us if we have nonpolar, polar, covalent, nonpolar covalent, polar covalent, or ionic. So here's an example of a table right here. When we look, you may notice as you're going down, it's decreasing. Well, remember, these guys are getting bigger, and they're not as quite interested in the atoms here. And you see that same general trend over here. Now, if you notice, if you're going across, it gets a little bit bigger, then it gets a little bit smaller, then it gets a little bit bigger. Okay, fluorine is the most electronegative atom there. It just absolutely is. No question about it. And then, of course, you have oxygen, and then chlorine and nitrogen. They're basically the same. So we can actually predict it, okay, given this table. And we'll work on that in class. So electronegativity difference and types of bonds. Well, if the difference is a 0, it's totally nonpolar, covalent nonpolar, electrons are shared equally. If it's like 0.4, between 0.4 and let's say 1.79, it's a covalent polar, where the electrons are shared unequally. Now this is where you start seeing the positive and negative charges there. The funny little symbols there tell you that it is a partial charge. It's not totally there, but yeah, there's definitely some there. Like this side here has some negative tendencies, but it's not totally negative. This side here has some positive tendencies, but it's not totally positive. Whereas in ionic, well, electron transfer, yeah, exactly. So these are the three possibilities. Like I said, metallic is its own beast, and we'll deal with it later. Okay, that's our basics here. And with that, ladies and gentlemen, we're going to stop here for Chapter 6A. I hope this benefited you. Hey, take care and have a good one.